Hey everyone, so today we are going to be talking about the biogeochemical cycles. So you've probably heard of a couple of these, like the water cycle and the carbon cycle, but today we're going to be going a little bit more in depth with them, and we're also going to be talking about the nitrogen and phosphorus cycles, and a little bit about how humans impact each of these cycles. Alrighty, so what are the biogeochemical cycles? Well, all matter is going to cycle through the biosphere. It is not just lost, but instead it's going to be transferred throughout all of these organisms. We were learning about the different food webs, right? So how are now the nutrients that we need in order to survive being moved around the earth? And the main ones we're going to focus on are water, carbon, phosphorus, and nitrogen. So they can happen, they're going to move around in 4 different ways. So there are certainly biological processes that exist. So those are activities performed by living organisms through things like eating, breathing, our elimination, are all ways that are biological that these nutrients can move around. You're also going to have geological processes that we'll discuss. That's volcanic eruptions, the formation and weathering of rocks, and just overall the movement of matter. You're going to have chemical and physical processes like running water, evaporation, lightning that we'll discuss. And then finally, human activity, right? We manipulate our world so much, so how is that affecting the nutrients? Things like mining, farming, burning of fossil fuels will all contribute to these geochemical cycles on a pretty grand scale. Alrighty, so let's get to our first cycle. This is the water cycle, so you guys should be pretty familiar with the water cycle. Water is so important to us as living organisms. We are made up mostly of water, and water covers about 71% of the earth, right? So that's a lot, and only about 3% of that is good for drinking water. So drinking, growing crops, we can only use a very small percentage of that. So some words to know are things like a reservoir. So a reservoir is basically where water is being stored. So this would be like our oceans, lakes, and streams. You can also consider the atmosphere a reservoir because there's tons of water vapor in the atmosphere. Alrighty, so let's start off with our ocean reservoir. Right, so we have, with our water cycle, we're at our reservoir, you're gonna have evaporation happening. So evaporation, now we have our atmosphere, right? The evaporation, water is moving upward. This is also happening similar, it's called transpiration from plants. So there are small pores in plants. And when it's very hot out, these plants do lose a little bit of their water, and that's called transpiration. So all of that now is contributing to the water vapor in the air. When it gets high enough, it's going to condense. So we have condensation with the formation of the clouds. Once there is too much condensation, that's when you get your precipitation. The water is going to come down, the snow will come down, and it'll seep into the soil. There's only so much the plants can take up. So once they're at their limit, you're going to have what's known as surface runoff. So the rest of the water will go and kind of find its way through the ground, either seep in through groundwater, right, go into those wells, or eventually lead its way back into the streams, lakes, and oceans, right, back into the reservoir. Alrighty, so now we're going to move on to carbon. So carbon we know was the most essential element we talked about. So it's going to be really, really important that we know this cycle. And there's going to be a whole bunch of different ways that we talk about this, right? The biological processes are going to be huge, right? So you have consumers, they're going to be eating plants that have carbon. So that's a way they can get them. You're also, when you're doing respiration, right, you're releasing carbon dioxide out into the atmosphere. That atmospheric carbon is going to be taken by the producers, right? And then when all of these organisms die, so any living organism passes away, the wastes or dead bodies get decomposed, and then all of that leftover carbon, right, gets compounded, will eventually turn into fossil fuels. Those fossil fuels, then we uptake that human activity piece of it. We get the fossil fuels, burn them, and the carbon dioxide ends up back into the atmosphere. So some terms you want to be aware of are things like carbon sink. So carbon sinks absorb more carbon than it releases. So this would be like your fossil fuels, right? Fossil fuels are a carbon sink. It's kind of housing all of these carbons. Living organisms too, we contain a ton and ton of carbon. We're constantly eating, taking in more carbon. Producers as well, right? They're taking in that carbon, making glucose. So they're absorbing more than they're outputting. Carbon sources now are going to do the opposite. So they're going to release more than they're absorbing. So carbon source is releasing more. This would be like burning of fossil fuels, volcanoes, fires, are all releasing a ton of carbon dioxide. So those are carbon sources. Alrighty. Next nutrient cycle, we have the nitrogen cycle. So nitrogen cycle here is going to be really, really important because it is used for the formation of amino acids. Amino acids make proteins. Proteins do everything for our bodies, right? So they're going to be really important here, especially for plants. They're going to be vital for their growth. So plants need nitrogen in order to survive and grow. They absorb nitrogen in the soil, and in order to do this, they need to have a symbiotic relationship with nitrogen-fixing bacteria. So we see here the nitrogen-fixing bacteria. So in their root system, those bacteria are going to do nitrogen fixation, which takes the nitrogen from the atmosphere. So no living organisms can use the nitrogen that's in the atmosphere and directly uptake it. So these nitrogen-fixing bacteria are going to do nitrogen fixation and make it usable for the plant. So then the plant can absorb it in its roots, and then obviously us as the consumers, right, the herbivores can go ahead and eat the plants, and that's how they're getting their source of nitrogen. When they do their waste, when they die, that nitrogen goes back into the soil. There's also another way we can do nitrogen fixation, so that is through lightning actually. So lightning, we have all this nitrogen in the atmosphere. When lightning strikes, it is actually going to also be nitrogen fixing. So we call it atmospheric nitrogen fixation. So that'll help a tiny, tiny bit the plants with uptaking the nitrogen. And then we also have what's called denitrification. So those bacteria are actually going to take any of the excess nitrogen in the soil and turn it back into nitrogen atmosphere. So that's going to be our cycle there. And again, not only is this important for our plants, but humans as well, right? We need to make tons of proteins, we need to make DNA, so the nitrogen cycle is going to be really important, that we have those nitrogen fixing bacteria, so the plants can uptake it, and then we can eat the plants and get our nitrogen. The human impact here is we use it for fertilizers quite often, so we need to introduce more nitrogen into our soils to try and grow more plants. Oftentimes our soils are so depleted of their nutrients because we've overused the land. So we'll put in all of these fertilizers in order to get our plants to grow. And sometimes we put too much nitrogen, and then you have runoff, right, the water from the water cycle, taking those nutrients and placing it in places that it shouldn't be, like our oceans, like our streams, and then you get things like algae blooms occur. Alrighty, finally we have our phosphorus cycle. So phosphorus cycle is going to look a little bit different where we don't have atmospheric phosphorus. So typically your phosphorus is going to be stored in things like mountains in the soil. So it's in rock mostly, so you have that geological uplift happening. It's in our mountains, and then as things like precipitation and wind are weathering those rocks, you get the phosphorus kind of weathering away and ending up in the soils. And then from, again, the rain, right, you have runoff. It is taking that phosphorus and bringing it to the different plants to get absorbed. It's bringing it into the oceans and rivers to end up in there. Once in the plants, consumers can uptake phosphorus as well and use it for things like their DNA and formation of their bones. And when all of these living organisms pass away, their phosphorus will end up back into the soil, eventually with geological uplift, right? That's how it ends up in our mountains. Alrighty, so that's going to be your phosphorus cycle in there. This also will look a lot like the magnesium cycle and sulfur that is readily available not in the atmosphere, but in rock and soil. Alrighty, and farmers will also use phosphorus in many, many fertilizers, accounting for algae blooms as well. Alrighty, so our last little bit is about nutrient limitations. So ecologists are interested in primary productivity. So this is the rate at which producers create organic material, and they're going to need things like water, sunlight, and those nutrients in order to be productive, right? Just to do their daily output, they need those three things. So if those things are lacking, right, they are not going to be as productive, they're not going to reproduce, they're not going to do their processes. So we also can call these things limiting nutrients, right? Things like potassium, nitrogen, phosphorus, carbon. They are our limiting nutrients because if they are not available, your organism is not going to be able to do their processes, and oftentimes could die off. Alrighty, so some limiting nutrients in the soil. This is going to be why farmers want to turn to fertilizers, right? If you overuse the land, there's not going to be as many nutrients in the soil, so they need to put down these fertilizers to get phosphorus, get nitrogen in that area in order for the plants to grow. A limiting nutrient in aquatic systems could be the nitrogen in the ocean and phosphorus. Right, so we shouldn't have that much nitrogen and phosphorus into the oceans, but because of the fertilizers, right, it is now from runoff bringing it into the oceans where now you can create algae blooms, right, because the algae is a producer. It's going to be using that nitrogen and phosphorus. You have this outburst of growth happening. So that could be a problem, right? Sounds good. Oh, we're getting more oxygen in the water. But really it's not, because those are living organisms, right? All of that algae is going to end up dying. And then because of that, you're going to now affect all of the other organisms in there. So now you have all of this decomposing matter in the water. Alrighty, so that's where we're going to end today. We're going to do a little bit more practice in class with the biogeochemical cycles. Please let me know if you guys have any questions.